Like what I got here is an ESC that I bought off of Amazon, and I got it connected to some terminals here and then some alligator clips so I can select whatever motor I'm going to go to. I wanted to balance them. I had some really bad vibrations coming through, and what I was ended up seeing. What I was seeing is in my videos when I was recording videos with my drone, as I was getting the jello effect really bad, and now this is like actually the probably the fourth time I've completely rebuilt this drone. And then this time when I rebuilt it, I ended up rebuilding it and buying new motors from Amazon. But the motors were screwed. We'll just say they were screwed from the beginning. So what I did was, I don't know if they're screwed. They fly and everything flies right, but the video quality was crap. Once I got it in the air, it was crap. So what I did was the first thing I did was I took my phone that I'm actually recording this on my phone. So, and I just kind of like, I unsoldered first. Let's do that. I unsoldered all the motor leads off of all of them. Okay. And I left them all attached to the drone. And then right here on top of this guy is where I set my phone on. And I had an accelerometer app that allows me to take a 2-second average or RMS of the vibration, the actual acceleration of it. And my initial settings were, my initial readings on motor 1 was 0.32 meters per second squared. Motor 2 was 0.22. Motor 3 was 3.32. And then motor 4 was the worst of all. It was at 0.96 meters per second squared. And then what I did was I took some of this foil tape that you use for like heating and ventilating and air conditioning, a little piece, and I cut literally like little tiny, like here's one right here, you can see there's the backing from it, little tiny squares, and I drew on them. So I said like, this is 12 o'clock position, right? And then this is obviously 3, and then this is 6, and then this is 9. And then I came through and I took, this guy is 0.96 because I was doing it in feet per second squared, and I decided ultimately that I wanted to go back to the meters per second squared because, well, there were lower numbers that made me feel better. But this one I calibrated completely off of that, and then I went back and got my final results back in meters per second squared, so it's back in what my initial reading was. So my initial reading there was 0.96 feet per second squared. Okay, that's feet per second squared. And then I applied that little square tape at the 12 o'clock position, ran it, did the 3 o'clock, the 6 o'clock, the 9 o'clock. And then I see here, like I determined that the 9 o'clock position, adding weight to the 9 o'clock position is what gave me the best result. Okay, so adding weight to the 9 o'clock position gave me the best result. Adding it to the 12 o'clock position gave me the worst, made it actually way worse. So what I knew is that anything I did in 12, 3, or 6 was going to be increase the value. So 12, 3, or 6, obviously biased towards 12. So I knew between 9 and more towards 9, but between 9 and 12, but more towards 9 is where I needed to, the weight needed to be added. So that would mean the equivalent to that would be between 3 and 6, but more towards 3. So I went to, let's see, that's motor 1. And you can see here on motor 1, I took sandpaper and I started filing down here at, that would be the 12. At 3 o'clock, I started filing more down. And then I got that down, and I went a little too far, so I took some off the 9 o'clock. And then I did another axis bias or another axis vibration on it. And every time I did, I made another measurement of what I was able to get it down to. So ultimately, I got it down to 0.98 with the first filing, and I got it from 0.60, which is weird because it actually got worse. I think I left the tape on or something. And then it slowly but surely started getting better. And where I ended up on that one was 0.14 meters per second squared. Now, motor 2 was 0.09 to start off with, and I was like, that thing, when I was running it and I was holding my hand on it, it was smooth as glass. I mean, obviously there's vibration there, but I'm going to allow a little bit for noise, and I figured anything anything below 0.15 meters per second squared would be good. So motor 2, I just left it just the way it was. Didn't touch it at all. I just left it the hell alone. Now the whole time I'm doing this, I have this thing running at a constant speed. So I have this hooked up to an Arduino Uno, and this measures the potentiometer position, and then it biases the RPM based on how I turn this thing up. So I got it to where it was a good place, right? I got it to where it was a good place where I knew it was, like I could feel the sweet spot of vibration. Like it wasn't too fast, because the faster you go, the less vibration you're going to have because it's moving so quickly. But if you go too slow, you're not going to get enough vibration. So I found with my fingers, I just felt that sweet spot, and I just left it there. And what I would do is I'd disconnect 2 of the phases. I'd just disconnect 2, and then do that, make my measurements, make my filings, my sandings, sand down the motors a little bit or whatever I had to do on each one, and then reconnect it, remeasure, and I kept doing that. So then we get to motor 3. Motor 3 started at 0.32. You can see where I put the piece of tape, what my old readings were. Best result was at 9, so I started filing at 3. And filing at 3, I went to 0.26, filed a little bit more, a little bit more, a little bit more. I did 2 measurements because I wanted to make sure, 0.15 and 0.17. So I did a third axis dynamic where I went to another filing on another one. So that's motor 3. That's this guy. So you can see here, I could measure directly between those two. So there's 12. And here's 3, 6. So between 3 and 6 and 3 and 6 is where I determined the most was. You can see how much I took off there. And I came and took a little bit off this side because I went a little bit too far. And that was when I took it a little bit too far. And I took that, and that last reading was 0.12. Motor 4 was, of course, the worst, 0.96. Here's all my readings. So once again, 0.83 at 12 o'clock. So I knew that my heavy spot was actually 6 o'clock. And that's confirmed by when I put the piece of tape at 6 o'clock, it went to 1.24, which is, like 33% increase in vibration. And I started sanding like hell at 6 o'clock. And I went from 0.96, first sanding was at 0.52, then to 0.22, 0.14, 0.12. And like I said, anything under 0.15 is good enough for me. So it's smooth as glass now, and I just wanted to kind of show that. So in case anybody wants any information, I can share any information on how I did this. Nothing here is copyrighted or whatever. If you have questions and you want to know how this is, let me know, and I'll for sure share this with you, because it's all about the community, and that's what I'm about. So thanks for watching. I know this was a long video, but I felt this important. So thanks.